As in continuation with our last lecture, for the precipitation of group 3 cations, we had discussed the reason for adding ammonium chloride and ammonium hydroxide as the precipitating agent for group 3. Moving on to the analysis of group 4 cations, the group 3 centrifugate, which is obtained after adding ammonia and ammonium chloride and separating out group 3 as a residue, and group 4 in the centrifugate is taken and ammonia solution is added in excess. After that, H2S gas is passed through this. The solution is then checked for complete precipitation on passing H2S gas in excess. Then the solution is boiled and centrifuged. If a residue is obtained by the above procedure, that is on passing H2S after adding ammonia, then that residue contains sulfides of group 4 cations, which may be cobalt, nickel, manganese or zinc, and they have precipitated in the form of their respective sulfides as cobalt sulfide, nickel sulfide, manganese sulfide and zinc sulfide. And in the centrifugate, we will be testing for group 5 onwards. If in this case the residue is not obtained after passing H2S, then that means group 4 cations are absent. So if the residue is obtained, then if that residue is black in color, as can be seen in the adjoining slide, then it contains precipitates of cobalt and nickel as their sulfides. It can also contain precipitates of manganese as well as zinc sulfides. But if the residue is buff in color, buff means light pink in color, then that means manganese sulfide has precipitated out. And if the residue obtained is dirty white in color, then that means zinc is present in the mixture as zinc sulfide. The group 4 residue is then taken in a semi-micro test tube and then washed with ammonium chloride solution. After that, dilute hydrochloric acid is added and the solution is stirred well, and this is then centrifuged. Upon centrifugation, the residue will be obtained which contains cobalt as cobalt sulfide and might contain nickel as nickel sulfide. And in the centrifugate, we will be testing for manganese and zinc, because the centrifugate contains manganese as zinc in their soluble portions as manganese chloride and zinc chloride. So dilute HCl is the reagent which is separating cobalt and nickel from manganese and zinc. Coming to the residue part, the residue which is black in color might have cobalt as its sulfide and nickel as its sulfide. So how to find out which of them is present? The residue is dissolved in aqua regia in a crucible and the solution is evaporated to dryness. The residue which is obtained after evaporating the solution to dryness which is present in the crucible, if the residue is blue in color, it confirms the presence of cobalt ions, and if the residue is yellow in color, then it is due to the presence of nickel ions. And this color of cobalt residue and nickel residue can be seen in the adjoining pictures. After the extraction of the precipitate in aqua regia, the solution is now divided into 3 parts. To the first part, excess of solid potassium nitrite and acetic acid is added. If a yellow precipitate is obtained, it confirms the presence of cobalt ions in the mixture, and the chemistry which explains this is cobalt sulfide, which has been formed after passing H2S along with HCl and nascent oxygen, which is the combination of aqua regia, gives cobalt chloride. That means cobalt sulfide dissolves in aqua regia to form cobalt chloride. Similarly, nickel sulfide, which is a black residue, dissolves in aqua regia to form nickel chloride, and they have been evaporated to dryness to give their residues, which can be extracted in water. So, cobalt chloride on the reaction with potassium nitride in the presence of acetic acid forms potassium cobaltine nitride, which gives a yellow precipitate and hence confirms the presence of cobalt ions in the mixture. To the second part, a small amount of acetic acid and a small amount of ammonium thiocyanate solution is added. After that, 1 ml of amyl alcohol solution is added and then this solution is shaken. If a deep blue color in the alcohol layer is observed, then it confirms the presence of cobalt ions in the mixture, and this deep blue color can be seen observed as in the adjoining figure. This deep blue color is due to the formation of cobalt thiocyanate complex, which is formed by cobalt ions here, which dissolve in the alcohol layer to give a deep blue color. To the third part of the solution, wherein the cobalt and the nickel sulfide residue have been extracted in aqua regia, 0.5 grams of solid ammonium chloride is added and then 0.5 ml of ammonia solution is added to this third part along with 1 ml of dimethyl glyoxime solution. This dimethyl glyoxime solution is prepared in 1% alcohol and 1% acid, sulfuric acid. If upon adding DMG or dimethyl glyoxime, red color precipitates, to be precise pinkish or rose red color precipitates are observed, then they confirm the presence of nickel ions in the mixture. So, we have two tests which we have performed for the detection of cobalt ions, wherein the first one was involving the addition of potassium nitride. The second one was with amyl alcohol. These two tests confirm the presence of cobalt ion in the mixture, and the third test confirms the presence of nickel ions in the mixture, wherein a nickel DMG complex is formed as follows. This is the structure of the nickel DMG complex and the reaction which shows that how nickel reacts with DMG, dimethyl glyoxime, to form the complex which is red precipitates observed. Coming to the centrifugate, which contains zinc as zinc chloride and manganese ions as manganese chloride. This centrifugate is boiled well to remove H2S. Then slowly excess of sodium hydroxide solution is added. If a residue is then obtained, it is centrifuged. The residue, if obtained, contains manganese as manganese hydroxide, and in the centrifugate we test for zinc as zinc sulfate, sodium zincate. Zinc sulfide dissolves in sodium hydroxide to form sodium zincate, whereas manganese reacts with sodium hydroxide to form manganese hydroxide precipitate. This is how the chemistry is explained in the following equations. Now, coming to the residue containing manganese hydroxide, it is taken and dissolved in dilute nitric acid. So, manganese hydroxide dissolves in nitric acid and then it is divided into two parts. To the first part, a pinch of red lead, which is also called lead dioxide, is added and the solution is boiled. This solution is then allowed to stand. If there is an appearance of pink color in the upper layer, it confirms the presence of manganese ions in the mixture. So, the equation which explains the above test is as follows. Manganese hydroxide reacts with hydrochloric acid to form manganese chloride. Manganese chloride reacts with lead dioxide or red lead to form permanganate ions, which are pink in color. As we know, potassium permanganate, which is pink in color, this is how permanganate ions which are being formed. Lead dioxide is an oxidizing agent and it is oxidizing manganese in the +2 state in manganese chloride 2 manganese in the +7 state in permanganate ions. So the solution goes from colorless +2 state to pink +7 state of manganese, and this is how manganese is confirmed in the mixture. To the second part of the centrifugate is taken in a test tube and 5 drops of concentrated nitric acid are added to it, and then the centrifugate is boiled. After that, a pinch of solid sodium bismuthate is added and the test tube is shaken. The solution is then centrifuged in a centrifuge tube. If upon performing the above procedure there is an appearance of pink color, it confirms manganese in the mixture, pink color in the solution. So this is the equation which is explaining the above procedure. Manganese chloride reacts with sodium bismuthate in the presence of nitric acid to form permanganate ions which are pink in color, and along with that bismuth precipitates as bismuth ions and sodium nitrate is formed. Then is the analysis of the centrifugate which contains zinc ions as sodium zincate. Till now we have analyzed manganese ions. Now coming to the centrifugate part, in which we have to describe or discuss zinc ions as sodium zincate. We take the centrifugate and divide it into 2 parts. To the first part, acetic acid is added and then H2S is passed through it. If white precipitates are obtained upon passing H2S, then these white precipitates are of zinc sulfide, and the reaction which is explaining this is sodium zincate along with acetic acid on passing H2S forms zinc sulfide, which is giving a white precipitate, and this confirms zinc in the mixture. To the second part of the centrifugate, potassium ferrocyanide solution is added, and every reagent which needs to be added is to be generally in equal amounts. That means if 1 ml of the centrifugate is taken, then 1 ml of potassium ferrocyanide or K4FeCN6 is added. If upon adding potassium ferrocyanide, bluish white precipitates are obtained in the solution, it confirms zinc ion in the solution, and the adjoining slide shows exactly the color of the bluish white precipitates of zinc ferrocyanide, which is shown in the following equation. Sodium zincate reacting with potassium ferrocyanide giving zinc ferrocyanide, which is a bluish white precipitate, confirming the presence of zinc ions in the mixture. Now for the precipitation of group 4 cations, we have added first ammonia solution in excess and then H2S has been passed. The reason for adding ammonia solution here before passing H2S for group 4 is explained as follows. Ammonium hydroxide is weakly dissociated to produce ammonium ions and hydroxide ions. As we all know, ammonia is a weak base. H2S again is weakly dissociated to produce H plus ions and sulfide ions. By considering the two dissociation reactions, it is observed that H plus ions and hydroxide ions, H plus ions produced from the dissociation of H2S and hydroxide ions produced from the dissociation of ammonium hydroxide, they both combine to form water. This pushes the reaction in the forward direction. Hence, the concentration of sulfide ions which are produced here is large. Since the reaction is now proceeding in the forward direction, so more and more H2S is getting dissociated to produce more and more H plus ions, and the concentration of sulfide ions also increases in this manner. Therefore, the concentration of sulfide ions is large and is sufficient to precipitate the group 4 cations as their sulfides. Since group 4 cations need a larger concentration of sulfide ions to precipitate as their sulfides. Now moving on to the analysis of group 5 cations. The group 4 centrifugate which is obtained after separating group 4 cations is taken and analyzed for the cations of group 4. The group 4 centrifugate is boiled for 2 to 3 minutes to remove the H2S gas. The solution is then concentrated to 1/5 of the original volume. After that, ammonium chloride, small amount of ammonium hydroxide and again a small amount of saturated solution of ammonium carbonate is added to it. The solution is then heated and centrifuged. If upon heating and centrifuging a residue is obtained, then that residue is due to the carbonates of group 4 cations, and they include cations barium, calcium and strontium. That means barium has precipitated as barium carbonate, calcium also as calcium carbonate and strontium also as strontium carbonate, and all these carbonates give a white residue. Now in the centrifugate we then proceed on for the analysis of group 6 cations. Coming to the residue which contains the group 5 cations, the residue is washed with little hot water and then it is dissolved in a minimum quantity of acetic acid. The residue of barium carbonate, calcium carbonate and strontium carbonate dissolves in acetic acid to give their acetates respectively, which are soluble. That means all these 3 carbonates dissolve in acetic acid to produce a soluble portion of barium acetate or calcium acetate or strontium acetate. After that, a small portion of this solution is taken and is treated with potassium chromate solution. If upon addition of potassium chromate solution, a yellow precipitate of barium chromate is obtained, then we need to pass potassium chromate through the whole solution. That means if a yellow precipitate is obtained on adding potassium chromate to a small portion of the solution of soluble barium, calcium and strontium acetates, then that yellow precipitate is due to barium ions, because barium ions have precipitated as barium chromate. So if a yellow precipitate is obtained, then potassium chromate needs to be added to the whole solution. If not, then the solution can be directly tested only for calcium and strontium ions. So we assume that barium ions are there in the mixture and potassium chromate is added to the whole of the solution. So the yellow precipitates are obtained of barium chromate, wherein barium acetate reacts with potassium chromate to form barium chromate, and this is giving the yellow precipitate. This yellow precipitate or the residue is further confirmed for the presence of barium ions. So a paste of this yellow residue is made in concentrated HCl and the flame test is performed with it with the help of a platinum wire. If an apple green flame is seen, then it confirms the presence of barium ions in the mixture, and this is the color of the apple green flame which you can see in the adjoining figure. And always a paste of the residue or the mixture directly can be made in concentrated HCl for performing the flame test, since chloride salts are highly volatile and they evaporate quickly in the presence of flame, producing required colors. Now in the centrifugate part, which might contain calcium and strontium ions, to this a saturated solution of ammonium sulfate is added. Then this is heated and further centrifuged. If upon addition of this ammonium sulfate solution, if any kind of residue is obtained, then that residue will be white and it will be of strontium sulfate. To confirm this, the flame test is performed just as the flame test was performed for barium ions. So this flame test, when performed, gives a persistent crimson red colored flame. Persistent means which stays, the color which stays in the flame for about a few seconds. Then this crimson red color flame confirms the presence of strontium ions in the mixture, and this color can be seen in the adjoining figure. So the equation which explains where strontium ions react with ammonium sulfate, giving strontium sulfate, which is a white precipitate. This white precipitate is taken and the flame test is performed, which gives a crimson red persistent flame. If to the centrifugate a saturated solution of ammonium oxalate is added and a white residue of calcium oxalate is obtained, then calcium can be confirmed in the mixture by performing the flame test. Again, the flame test is performed in the similar manner as earlier, and if a non-persistent dull red or brick red color flame is obtained, it confirms calcium ions in the mixture. Non-persistent means that this color of the flame will come and immediately go within 1 or 2 seconds. So, the equation explaining this is calcium ions react with ammonium oxalate to produce calcium oxalate white precipitate, and this white precipitate is used further for the confirmation of calcium ions by the flame test. Coming to the analysis of group 6, which is also called group 0, because this group can be tested directly with the mixture in the beginning also, because these cations which are belonging to group 6 are both soluble in water. So, a water extract of the mixture can be prepared, and these two cations which are potassium and magnesium belonging to group 6 can be performed directly initially with the mixture also, or the analysis of group 6 can also be done with the group 5 centrifugate. So, group 5 centrifugate, which is obtained after separating the carbonates of group 4 cations, is then evaporated to dryness in a nickel crucible to remove all the ammonium salts. Since till now in group 3, 4, 5 we have added a lot of ammonia and ammonium salts which need to be removed before the analysis of group 6, because all these ammonium salts will interfere in the analysis of group 6 cations otherwise. After evaporating the centrifugate to dryness, if a residue is obtained, then it is dissolved in water to make an extract, as just mentioned earlier that the cations belonging to group 6 are soluble in water. So, they can be detected even in the beginning of the mixture or with the group 5 centrifugate. In this extract, potassium ions and magnesium ions belonging to group 6 as just discussed are analyzed. Now, this water extract is divided into two parts. To the first part, a small amount of sodium cobalty nitride solution is added. If a yellow precipitate is obtained, it confirms potassium ions in the mixture, and this is the equation which is explaining this. Potassium ions along with sodium cobalt on reaction with sodium cobalty nitride produce potassium cobalty nitride, which is giving a yellow precipitate and hence confirming the presence of potassium ions in the mixture. To the second part, which is the water extract, a small amount of disodium hydrogen phosphate is added, and then this solution is cooled in ice. If white crystalline precipitates of magnesium hydrogen phosphate are obtained, then it confirms the presence of magnesium ions in the mixture. Magnesium ions on reaction with disodium hydrogen phosphate give magnesium hydrogen phosphate, which is giving a white crystalline precipitate. This white crystalline precipitate is soluble in hot solution and will precipitate out only when the solution is cooled in ice. And as already mentioned, potassium ions and magnesium ions are soluble in water, so they can be detected in the start of the scheme of the analysis. And as already discussed, there are some cations which tend to precipitate out as their sulfates or fluorides, which are considered as insolubles, that means which are insoluble in any kind of original solution. Such kind of cations need to be analyzed under a separate scheme of insolubles of mixture analysis which has not been included in the main scheme, because they are the ones which are insoluble in the original solution. So this is how we detect the cations by following a systematic analysis, and the anions also following a systematic analysis of the mixture, wherein the anions need to be analyzed first. The reason for anions need to be analyzed first is that if there are any interfering anions present, then they can be removed so that they do not interfere in group 3 analysis of the cation onwards. Since all these interfering anions, they tend to precipitate out as soon as the medium changes from acidic to alkaline from group 2 to group 3. So first anions need to be analyzed, and then cations need to be analyzed by a systematic procedure which helps us to determine the cations as well as the anions in the mixture. Thank you.